So guys, welcome to our channel once again. In today's video on WAEC Physics Exam Revision Series, we have here these 10 WAEC repeated questions to answer on the topic heat energy. So guys, this video will be about specific risk of fusion and vaporization. So ensure to stay till the end of this video. So let's go ahead and start with the first question here. It says, calculate the heat energy required to change 0.1 kg of ice at 0 degrees Celsius to water boiling at 100 degrees Celsius. So we are given the specific heat capacity of water and also the specific latent heat of fusion of ice. So guys, if we go ahead and calculate this, we're going to just use ml plus mc delta theta. So that will be the overall heat here. So the heat Q here will be the mass 0.1 kg times the specific latent heat here, that's 336,000 joule per kilogram. Then this plus the mass again, 0.1 kg times the specific heat capacity 4200, then times the change in temperature, that's 100 degrees Celsius, because this is 100 minus 0, so that's 100 degrees Celsius. So guys, if we have the product of this and add them together, we're going to have 75,600 joules, and that's option D here. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 2. It says, what is the difference in the amount of heat given out by 4 kg of steam and 4 kg of water when both are cooled from 100 degrees Celsius to 80 degrees Celsius? So we are given the specific latent heat of steam to be 2,260,000 joule per kilogram, and we're also given the specific heat capacity of water to be 4,200 joule per kilogram per Kelvin. So guys, if we're going to solve this out together, we're going to still have that Q here will be ml plus mc delta theta for steam, and then Q is equal to mc delta theta for water. So but guys, since the both of them have the same mass and the same change in temperature, that means we can say that if we subtract this, that's ml plus mc delta theta for steam minus mc delta theta for water, we're just going to have ml. So in that case, ml here is the mass 4 kg times the specific latent heat of fusion here, which is 2,260,000 joule per kilogram. So guys, if we multiply this by 4, 9,040,000 joules. So that's option B here. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 3. It says, a 10 ohm coil takes 21 S to melt 10 gram of ice at 0 degrees Celsius. Assuming no heat losses, determine the current in the coil. The specific latent heat of fusion is 336 joule per gram. So guys, with this, we are going to have that I square RT is equal to ml, where the mass is given here to be 10 grams, and then the specific latent heat of fusion is 336. Then also for I square RT here, I squared is not given, but R, which is the resistance, is 10 ohm, and then T here is 21 seconds. So in that case, I squared, if we make I squared the subject of this equation, we're going to have that I squared is equal to ml over RT. So ml is 336 times the 10 grams. So that's 3360 over RT here is 10 times the 21 seconds. That's 210. So 3360 over 210, that's 16. So it means that I squared is 16. So if I squared is 16, I alone is going to be root 16, and that's 4 amps. So that's it for this question, option B. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says, water of mass 120 gram at 50 degrees Celsius is added to 200 grams of water at 10 degrees Celsius and mixture is well stirred. Calculate the temperature of the mixture. Neglect heat losses to the surrounding. So guys, let's go ahead and tackle this out together. So we can use the formula mc theta is equal to m1c theta 1 plus m2c theta 2. So guys, here in this equation, we have that the m here will be the sum of the masses, then the theta here will be the common temperature, and guys, m1 is mass 1, m2 is mass 2, theta 1 is temperature 1, and then theta 2 is temperature 2. So the sum of the masses here will be 120 plus 200, and that's 320 grams. So in that case, it means that 320 grams times C times theta will be equal to 120 grams times C times theta 1 here is 50. So 120 grams times C times 50 plus 200 grams times C times 10. So guys, noting that C is common here, we can eliminate C, cancel out the C's here, then solve for theta. So theta will now be m1 theta 1 plus m2 theta 2 all over m. So that's like 120 times 50 plus 200 times 10 all over 320. So guys, when we solve this out together, we are going to have 6000 plus 2000 over 320, and that's 8000 over 320, and finally this will give us 25 degrees Celsius. And guys, that's option B here. So let's go ahead and consider the next question. So guys, the next question here is question number 5. It says, calculate the quantity of heat released when 100 grams of steam at 100 degrees Celsius condenses to water. So guys, here, in order to solve this, we're going to use H is equal to ml. So the mass here is 100 grams, and since our specific latent heat of vaporization here is in joule per kilogram, we're going to convert this 100 grams to kilograms. That's 0.1 kg. So we'll multiply this by the L, which is the specific latent heat here of vaporization. So that's 2.3 times 10 to the power of 6. So when we multiply this by this 0.1, we're going to have 2.3 times 10 to the power of 5, and that's option D here. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 6 here. It says a 90 watts immersion heater is used to supply energy for 5 minutes. The energy supplied is used to completely melt 180 grams of a solid at its melting point. Neglect energy loss to the surrounding. calculate the specific latent heat of fission of the solid. So guys, looking here at the option, we have the specific latent heat options as joule per gram. So we can always leave this mass in gram here, but then the time here in minutes we can change it to seconds, and that's 5 times 60 seconds, so that's 300 seconds. So using the formula PT is equal to ml, so we're looking for L here. We'll make it the subject of this equation, so that's PT over M. So in that case, the power is 90 watts, the time is 300 seconds, and the mass is 180 grams. So this will give us 90 times 300 over 180. So guys, the answer to this question will be 150 joule per gram. And that's it for this question. So let's go ahead and consider the next question, guys. This is question number 7. It says, the amount of energy required to change a kilogram of ice block into water without a change in temperature is A. Specific latent heat of vaporization of ice. B. Heat capacity of ice. C. Specific heat capacity. D. Specific latent heat of fission of ice. So guys, the answer to this question here is option D. That's it. So let's go ahead and consider the next question. So guys, the next question here is question number 8. It says, calculate the energy required to vaporize 50 grams of water initially at 80 degrees Celsius. So the specific heat capacity of water is 4.2 joule per gram per Kelvin. And then the specific latent heat of vaporization here is 2260 joule per gram. So guys, actually the energy required here can be stated as ml plus mc theta. So the mass here is 50 grams, so no need of conversion since we already have the specific heat capacity at joule per gram per Kelvin. So we have this as 50 grams, then times the L, which is 2260, plus M, that's 50 grams, times C, which is 4.2, then times theta here, which is the change in the temperature. So let's notice that at vaporization, we have 100 degrees Celsius. So 100 minus 80, that will be 20 degrees Celsius. So this will be multiplied by 20 degrees Celsius. So when we find the product of this and add together, we should have 117,200 joules. So that's it for this question. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 9. It says, the specific latent heat of vaporization of lead is 8.7 times 10 to the power of 5 joule per kilogram. This means that 8.7 times 10 to the power of 5 joule of thermal energy is required to change A. 1 kg of molten lead to vapor for every degree rise in temperature. B. A given mass of molten lead to vapor at constant temperature and pressure. C. 1 kg of molten lead to vapor at constant temperature and pressure. D. 1 kg of solid lead to vapor at constant temperature and pressure. So guys, the answer to this question is option C here. The specific latent heat of vaporization being 8.7 times 10 to the power of 5 means that this 8.7 times 10 to the power of 5 joule of thermal energy is required to change 1 kg of molten lead to vapor at constant temperature and pressure. So that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question 10 here. It says, which of the following statements about latent heat of vaporization is correct? It's A. Weakens the adhesive forces between molecules of a liquid and those of its container. B. Adds to the heat content of a liquid. C. Breaks completely the force of attraction between the molecules of a liquid. D. Increases the cohesive forces between liquid molecules. So, guys, the answer to this question is option C here. It actually breaks completely the force of attraction between the molecules of a liquid. And that's it for this question. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll be sure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. So this will help you a lot even as you prepare for your WAEC examination for the year. So thank you once again for watching this video and see you on the next one.